Hey, physics guys, here is the video that I promised. We're going to go through the problem solving, and we've gone through some of this in class, but I want to take this time to solve these problems. Here we go. A girl rides her bike at 15 meters a second for 20 seconds. How far does she travel in that time? Obviously, this is super simple. The distance is equal to the rate or the velocity times the time. So what you're going to do is you're going to go ahead and multiply that 15 meters a second. So that distance, is 15 meters a second times 20 seconds. And that's going to equal 300. And I'm just going to put all the units there, meters times seconds, because that's on top. That's like seconds over 1. So meters times seconds, meters seconds, over seconds. Over seconds, this is my dimensional analysis. Those seconds cancel, so it's really 300 meters. And I know that's, a little bit too much for you, but I need you to keep thinking in those terms. 300 meters. We're looking for distance. How far does she travel? 300 meters. And then the next question says, how fast would the girl in the previous problem have been traveling if she covered that same distance in 11 seconds? Okay, so we're going to say the distance, 300 meters, equals some unknown velocity. How fast would she have to be traveling? And multiply by 11 seconds, right? Parentheses and this little dot here mean the same thing. I like to use parentheses. So how are we going to solve this? Obviously, we're going to divide both sides by 11 seconds. I need to get my calculator out. Give me 1 second while I get a calculator out. Hopefully this one works. Sorry about the bell. All right, let me pull my phone up. And come on. 300 divided by 11 is 27.27, right? So the velocity, those things cancel. And that is 27. Sorry it took so long. And sorry about the bell. Class just ended. Meters over seconds, or meters a second. Hey, look at that. This is a repeating 27. Just go ahead and leave it like that. And we're good to go. Let's get rid of this one. And go to the next layer. There it is. I want to draw on it, so I'm going to choose over here. Now, it says refer to the chart below. There's no A through E. I'll fix that in a jiffy. There's just A and B for this, okay? This says draw a position time graph. Now, I can draw straight lines because I'm, lucky I'm using a graphics pad. So here's my y-axis. Here's my x-axis. And I'm going to go ahead and draw on it. I got to get rid of this. Okay, so here's 10 meters, 20 meters, 30 meters, 40 meters, 50 meters, etc., right? Here is 1 second, 2 seconds, 3 seconds, 4 seconds, 5, 6, etc. All right? So I'm going to put a dot here at 1 and 10, 2 and 20, 3 and 30, 4 and 40. Oops. Let's undo that. Got out of hand there. And obviously it goes way up here. Way up here. Right? And I just want to show you what it's going to look like if I use these numbers, right? So I'm going to put my straight line here. It sort of fits right in there. But then this sucker shoots way up. It has a much steeper slope. And that's basically what your graph is going to look like, okay? And you'll do your best. You'll label it. If you don't label it, then I don't know what's going on. So 10, 20, etc. And then 1, 2, etc. Make sure this is position and this is time. Okay, just be able to label it like that, position and time, and show me the graph. Great. The next part of this is, what is the average velocity from 1 second to 4 seconds? Okay, from here to here, what is this slope of this line? And so we go, all right, well, slope equals rise over run. So velocity is change in position over change in time. So my change in position, we went from 10 meters up to 40 meters, right? Or we go from 40 meters minus 10 meters, and we went from 4 seconds to 1 second, right? That's my change. So that's 30 over 3. 30 meters over 3 seconds. So my average velocity down here is 10 meters per second. Cool? There it is. Change in position over change in time. That's my velocity. Cool? Let's move on. Get rid of that. I think it's this guy here. Yeah. This one was that easy one that I had you do 2 different ways. You could just find the average, right? So it says you're planning a bicycle trip and you want to average 24 kilometers an hour. You cover the first half in 21 kilometers an hour. What do you have to average in the second half to meet your goal of 24 kilometers an hour? So you say, I want my average to be 24 kilometers an hour. My first half is 21 kilometers an hour. My second half, I don't know, divided by 2, right? Because that's how you find your average. Well, how do I solve this? Well, we just go ahead and solve and multiply by 2. Multiply by 2 because we want to get rid of that fraction. That cancels with this, that cancels with this. So now we have 48 is equal to 21 plus x. And all I want to do is isolate that variable. So what am I going to do? I'm going to subtract 21 from both sides. Sorry about my 2 different 2's. Looks horrible. So 27 equals x. Right? So my answer is 27 kilometers an hour. Sound good? Now, is there a simple way just to reason this out? And my answer to that question is, yeah, there's a super simple way to reason this out. And I'm going to show you just by showing you a line. Here's a line, right? Yeah, get rid of that. And I'm going to say, here's what I consider the center of the line, and this is my 24, my average, the thing that I want, right? And over here is the first half, and I was at 21. Well, how far away is that? How far below 24 is that? Well, it's down 3, right? Well, for the second half, if I average plus 3, that makes up the difference, right? So if I added 3 to 24, I'd get 27. So there's logic. If you wanted to draw something like this, that's totally fine. And you still get the same answer. And you could still write 27 kilometers an hour. Good? And I guess we're at the last page. The last set. And this is same type of deal, isn't it? It says, and I quote, you have 6 hours to travel a distance of 140 kilometers. How long will it take you to travel the first half at an average of 21 kilometers an hour? So I sort of did this a little bit differently in class. And I messed up, so I'm going to fix it right now. How long will it take you to travel the first half? Well, the first half is 70 kilometers, right? And then we're going to use that same formula. Distance is velocity times time, right? And my average velocity is 21 kilometers an hour, right? Times however many hours, X hours, right? So if I divide 70 by 21, I should get my answer, right? Because that's how I get rid of this multiplication. I do some division. So I'm just going to show it to you. Let's divide by, 21, divide by 21. Wow, that was horrible. And let me get out my handy dandy calculator. Clear 70 divided by 21. I guess that's my next thing, right? So it's going to take me, it's going to take me 3 1/3 hours to go 70 kilometers. Okay, well, in the second half of the ride, you need to increase your average speed to make up for lost time, right? If you can maintain a speed of 25 kilometers an hour, will you be able to reach your destination on time? Okay, well, I need to know how many hours it's going to take me at 25 kilometers an hour in the second half, which is 70. So let's do it again. Let's say 70 kilometers equals 25 kilometers an hour times X, I don't know my hours right now, and see if this indeed gets us to 2 2/3. We need 2 2/3 to make that 6 hours work, right? Because we had 3 1/3 for the first 70 kilometers. I need at least 2 2/3 or less to make it the rest of the way. So let's find out. 70 divided by 25. And I guess I'll show it to you visually. Divide by 25. Divide by 25. I'm sorry about the units. I know I just yelled at you for, you have to have your units right. KM, H, and then the KMs cancel out, and we have hours left.
It turns out that it's 2 8/10 hours. Now, 2 8/10 or 2 4/5. If you want to write this is 3.3 repeating, right? If we add these two things together, we're a little bit over the top, aren't we? We're like 6.1, 3. So we're over the top, right? And so show your calculations for average speed you need to maintain in the second half of the bike ride to make up for lost time. So you then say, I'm going to put in the right number of hours, right? And what I'm going to do is, instead of using 2.8 hours, I'm going to put in 2.6 hours. That'll get me just underneath it. So I'm going to do my 70 kilometers is going to equal some unknown speed or velocity, kilometers an hour, times, I guess I could do 2 2/3, right? And then, or let's do this. Let me fix this. Let's use a decimal, so because you guys are going to have calculators to do this. 2.67. Let's do that. Let's use 2.67 for 2 2/3. That's just about the right number, barely over, and it's going to help us out a lot. So if I divide by 2.67, 2.67, now I get back to my handy dandy calculator. 70 divided by 2.67 is just over. It's 26.22 or 26.22 kilometers an hour. And I'm not going to be a stickler for perfection here, but if I see something that's pretty close, I may tell you about significant digits when I get there. But that's it for you guys. The honors students will have other problems, but I'm not going to put them on this video. Thank you so much for your time. If you have any questions, please let me know as soon as you get into class. Thank you.